So another form in our journey into trigonometric equations that we are going to encounter is like a sine theta plus b cos theta is c, where a, b, c are constants. Now, how does one solve an equation of this kind? How does one solve an equation of this kind? Now, a sine theta plus b cos theta, there is a very regular way of dealing with this. The way is you divide by root a square plus b square. So when you divide by root a square plus b square, b squared sine theta plus b by root a square plus b squared cos theta is c by root a square plus b squared, right? Now what we do is, for example, I could have chosen this. See, the denominator is numerically large than the numerator. So I could have chosen a by root a square plus b square as some sine alpha. So sine alpha is like a by root a square plus b square, right? And this one, therefore, realize we've done this in the past in trigonometry. This will then turn out to be b by root a square plus b square will turn out to be some cos alpha, right? So then this equation reduces to where of course alpha is such that tan alpha is a by b. Tan alpha is a by b. Now we have sine theta sine alpha plus cos theta cos alpha is c by root a square plus b square is what we have. So cos a cos b plus sin a sin b, that makes it cos a minus b cos of theta minus alpha, right? Cos a cos b plus sin a sin b, cos of theta minus alpha is c by root a square plus b square. Now the important thing is that cos of theta minus alpha has to be a number lying between 1 and minus 1, right? Which means there will be a solution only if and only if this also lies in the interval minus 1 to plus 1. That means c by root a square plus b squared has to be less than or equal to 1 and greater than or equal to minus 1. And then that gives me like a c less than or equal to root a square plus b squared, but greater than or equal to minus root a square plus b squared. That means a solution to this equation would exist. A necessary condition for the solution to this equation is that c has to lie between minus root a square plus b square to root a square plus b square. So if I combine these two, it's about c squared not exceeding a square plus b square. C squared not exceeding a square plus b square. So let me just give you an example around this. So if I had an equation like say root 3 cos x plus sin x equal to root 2 cos theta, say, equal to root 2, and I want to solve this equation. What do? I multiply by root a square plus b square. That means a in this case is say root 3 and b in this case is 1, right? So root a square plus b squared, root a square plus b square is 3 plus 1 4, which is 2. That means I divide both sides by 2, right? Now this root 3 by 2 is what? Cos of 30 degrees, cos of pi by 6, right? So I could have written this as cos theta into cos pi by 6, cos 30 degrees. And then this half is like sine 30 degrees, sine pi by 6. So then this is like plus sine theta into sine pi by 6 equal to root 2 by 2, which is 1 by root 2, which is cos 45 degrees, cos pi by 4, right? So we then have cos a cos b plus sin a sin b is like a cos a minus b. Theta minus pi by 6, cos of theta minus pi by 6 is cos pi by 4. Is cos pi by 4. Yes or no? Can you see all of this? Right? Cos of theta minus pi by 6 is cos pi by 4. Can you see this? Right? Which means if cos A is cos theta is cos alpha, what's theta supposed to be? Theta minus pi by 6 is 2n pi plus minus alpha. That's the result that we learned. Plus minus pi by 4. Right? And theta therefore, where n is any integer, theta therefore is going to be 2n pi plus minus pi by 4 plus pi by 6. Yes or no? Right? So then, this again is an important and a very relevant form of trigonometric equations, and the way to solve this is divide by root a square plus b square, convert it into a compact form, cosine of something minus something, and then make sure that c square does not exceed a square plus b square. C square has to be less than or equal to a square plus b square, so that c or mod c, in fact to be more precise I should say mod c square greater than or equal to this. That means c, the number c has to lie between minus root a square plus b square to root a square plus b square. The numerical value of c should be less than root a square plus b square. That means the solution would exist only if mod c is less than or equal to root a square plus b square, which would tantamount to c floating between minus root a square plus b square to plus root a square plus b square. Thank you so much.